Thank you everybody for being here today. It is my pleasure to introduce our speaker today, Currie from University of Southampton. And she gladly accepted my invitation to come here and give a seminar for us. So she will, I guess, she will explain about these topics, which are part of her research. Also in collaboration with one Spaniard, Antonio Martinez Skura. It's a Czech name. So yeah, so Tony is also a Spaniard that he's currently working at the University of Southampton with her, and he comes from Valencia, or from University of Valencia, so it's a good place to come from. He's a mathematician also. So Christine will give this presentation, and I asked her also to give us some recommendations regarding, since she's also editor-in-chief of Journal of Simulation, which is one of our favorite journals, of course. So I asked her to give us some ideas about, or some recommendations about how to write good papers, and which how to make sure that what you submit is in shape, is in good shape. So Christine, thank you for being here today.
Can you hear me okay? I think that's not on mute now, so you should be able to hear me. So thank you very much for inviting me and for coming all this way to hear me. So I'm Christine, I'm at Southampton. I've been at Southampton for about 15 years. I did my PhD there before I became part of the faculty. So let's go now to the ferry. We'll do probably. So our objective of the whole research is to derive this dynamic pricing policy that maximises the expected revenue from the sale of vehicle tickets on a ferry. And we're looking at each crossing individually at the moment. We're not considering people going, not buying the 9 o'clock and buying the 10 o'clock instead. So we're assuming they're all just going for this one crossing. The constraint, and this is the big one, is the capacity of the vehicle deck, and how many we can fit on that vehicle deck will depend on how well we pack them. So if you have a poor pack, you put a lorry in the wrong place and the cars can't get round it, or a big vehicle in the wrong place, then so customers arrive during the selling season. So about 6 months from departure, they'll start selling tickets, and what we want to know is how much should they charge. And you can see common sense kind of dictates if you've got a big vehicle, you should charge it more because it takes up more space. But maybe you should charge it even a little bit extra because a big vehicle is awkward to pack. And it's getting in those ideas of how awkward it is to add these bigger vehicles and how easy it is, say, to fit in a motorcycle somewhere in between all these gaps. And those ideas which we're hoping will govern what prices we charge. So that's where the packing comes in. Now, on top of this, customers have a willingness to pay, which is the probability that, given that the ticket is there, they will actually purchase the ticket. And you will actually find in reality that the bigger vehicles have a much lower willingness to pay than the smaller vehicles. So the situation we're talking about here is an island, the Isle of Wight. I think one person in the room will know where the Isle of Wight is, but maybe not so many others. It's a small island which you can get to from Southampton. It takes about 20 minutes on the ferry to get there from Southampton. There will obviously be residents who will come and work on the mainland and vice versa. But there are also all their goods, everything they sell in their shops, everything they use will come in on this vehicle ferry. So it's also bringing in a lot of the freight. And these freight vehicles that are coming every week, all through the year, will have a much lower willingness to pay than the tourists who go over for their summer holiday in the summer. So we have to take that into account as well. Vehicles also vary in shape and they vary in size. So this is a Tony video which he put together. And we have this start of the selling season and the departure and, well, animation rather than video. And we have discrete time, so we split our selling season up into discrete time. We make the assumption that we can have at most one arrival per time period. And that's a fairly standard one in the literature. So we might have in the first period, no one arrives. Second period, no one arrives. In the third period, a car arrives, and we want to know how much to charge that car. Now, the car might, or the person buying the ticket for the car might arrive, and they might see the price and decide that they don't want to pay it, or they might arrive and see the price and decide they do. So those are kind of considerations that we have to take into account. Then we have a set with nothing, and then we have a bus arriving. Now, obviously, if we accept the, depending on the size of the ferry, these ones are normally big. If we had a small ferry, we accept the car, we accept the bus. It may be then difficult to fit in kind of something booking later on that might be prepared to pay a higher price because we're closer to departure and just can't fit onto the ferry. So how much do we charge for that bus to ensure that we have enough space left for these high-value vehicles? Then we have a car, and I think we have some freight vehicles, and then I think right at the end we have a tractor that arrives. So we don't have, the Isle of Wight is a very big sailing community, so the strange vehicles are usually a van pulling a huge big super yacht of some description, maybe not a super yacht, but a huge big yacht or big boat. So you have these strange vehicles with different height restrictions, different lengths, different widths that you have to take account of. So the packing is not straightforward. So the company we're working with is Red Funnel, and they have regular crossings between Southampton and the Isle of Wight, as I've said. There will be lots of vehicles, private vehicles, so individuals coming over, and these commercial freight vehicles as well. And the ferry is split into a few different decks. So I won't go into all the details, but basically there's a car deck, there's a main deck, and then there are these collapsible decks that you can have if there isn't much freight and you've got lots of cars, you can put one of those in. It lowers the roof, but it means you've got an extra deck of cars. So these are called mezzanine decks. Generally on the car deck, cars will park in lanes, but not on the main deck where you've got a mixture of cars and freight. Some things may overlap the lanes and you may end up with a different pack, which makes the packing more interesting. And these are some pictures. We spent a nice day going backwards and forwards on the ferry, looking at what was going on. This shows the mezzanine deck up here, so it's got cars on it, but you can see underneath that you couldn't get anything very tall. So it does restrict the capacity on the main deck. And this is the car deck. So having said everything goes in lanes, we then watch the loaders park things diagonally. So it doesn't always fit as well as, fit the maths as well as you might think. Now this is showing how the simulator comes in. So up until this point, we can solve this problem, and we can solve it exactly using integer programming methods and combining those with a dynamic program, which we'll look at a bit later. But that only gets you so far. It will solve fairly small instances, but won't get you to the really big ferries and the real practical instances. So our aim is to solve this real-world problem. So that's where the simulator comes in. So we have a loading simulator that we've built that generates some random demand, and we'll then look at how it loads that demand. And we'll take into account, we'll have a loading rule for how it loads, which vehicle does it pick first, which vehicle does it pick, which position does it choose to place that vehicle in. For example, these are the packing rules. And it will take into account kind of practical details like the vehicles that need to be by a lift because there's somebody who can't walk very well. If there's a accept strange load, there's a big prison on the Isle of Wight, for example, so they will sometimes have the prison vans on there and they need to have a bit of space around them while they're on the ferry. So there'll be strange loads on there that need special requirements, and the simulator takes into account all those special requirements in a way that the linear programming couldn't do in a practical setting. Now actually how well we do the loading, how well this packing works is quite important, because if our simulator is packing badly, then we're going to come out with poor results for our prices. We will start overpricing things because we think they'll stop things fitting, but actually if we packed it a bit better, they would fit. So So we have a simulated annealing algorithm in there, which is setting our packing rules, and that's working with the simulation. So we've got the simulation running, we're doing some simulated annealing, it's setting the packing rules, they're being fed back into the loading simulator. And how this works is it gives us an idea of how much actual space a vehicle will take up. So if we add another car, it will obviously take up the area of the car extra, but it will take up some extra space because it might block someone in, it might block a particular area of the deck, and so it might cause some wasted space. And so these transition functions give us an idea of how much wasted space there is. These get fed into the dynamic program, which is affected, the states of that are how much space we have left on the ferry. And then as they're fed into the dynamic program, we can then optimize forward to find out what prices we should charge. And then outside all of that, we have a simulator for testing, which is just testing how well these prices work and what revenues we get out. So a little bit about the loading simulator. I've said some of it already, so I'll not go into lots of detail again. It simulates the online ferry loading process. The loading rules optimized by simulated annealing, and it measures the remaining space on each deck after each vehicle is loaded. So it says, this is how much I've got now, I load this vehicle, this is what I've got left, because I might have blocked space, for example. The other thing I didn't mention was it accounts for these parking gaps that are required so that people can get in and out of their cars at the end of at the start and the end of their crossing, because they get out their cars, they go up and sit in a cafe, and then they come back down and drive off. So this will take account for the parking gaps, and it's even at the level of detail. If something's parked, a big freight vehicle is parked next to the wall, then it needs less space on one side than a car, because it's likely the driver gets out one side rather than the other. So it's got quite a lot of detail in there about these gaps that you need to leave. Within the simulator, this loading algorithm, this is what I talked about with the simulated annealing, this is used to select which vehicle to load next and where to put it. So we generate possible positions, and you can look at them on a diagram. You know, there's a space here, there's a space here, there's a space here. And we order them in terms of a weighted sum of a number of efficiency-based criteria. So these might be distance from the far end of the ferry, so how near the front of the ferry I am, tightness, so how tight is that space in terms of the vehicle width and the parking position width. Obviously tight is good because you're wasting less space. Parking loss, this is what we call the space loss due to staggered parking, if you end up with a gap that you just can't get a vehicle into. Now, how much weight to put on each of these attributes, and the other ones we use, is something that we use simulated annealing to do, to improve that so that we get an optimal pack. What we're trying to do is make it as realistic as possible, because what the ferry company don't have is a really good feeling for how many vehicles they can fit on their ferry. So they will talk in terms of car equivalent units, but what they would like is something that says, this is how many I can actually fit on. So what we're hoping to do is kind of reproduce what the loaders are doing, the people who are putting the vehicles in the ferry, because they're very good at getting a very good pack. I think what the ferry company would like us to do is also help them improve their loading by showing them what we can do and what our solutions look like. So a little bit about the pricing. So there's lots of notation to start with. We have big T, number of time intervals in the selling season, and little t is the time period. We've got different vehicle types, as I mentioned before, which is this set I, and then each vehicle type will have a different arrival rate during the selling season. We assume they're constant at the moment, but it's relatively straightforward to make them non-homogeneous. We then assume we've got a discrete set of prices. So these P's are our prices that go between some lowest price and some highest price. And that's fairly standard for what's done. They don't have continuous prices. They will have a discrete set. This alpha is our willingness to pay. So what's the probability that, given we've got that price on offer and we're at this particular time, a customer of this particular vehicle type will accept that price and will actually purchase. So some customers will come and look at the prices and go away because it's too expensive. This is the probability they actually accept it. And then X is our current state, which is how much we've sold, how much space we have. Now, we formulate this as a dynamic program, which is something that's often done in the pricing world. So my background is a bit simulation and a bit in the revenue management area. So this is looking at it from a revenue management perspective and optimal pricing. So we're saying our optimal expected revenue from period T to the end of the selling season, if we're in state X, is equal to, now this is the person is buying the ticket, someone arrives, they buy, you get that immediate reward P, but in future time periods, you've got this VT minus 1 F of SI. Now this is the reward you have having sold that space to another vehicle. And this is why we need to know how much space that vehicle will take up on the ferry. Now the other option is that they arrive and they don't purchase, or that nobody arrives. And in that case, you go forward to the next time period with the same amount of space remaining. So this is where the packing bit comes in, is in working out this kind of function here. So states are defined by remaining area on the decks. We can do that in different ways. We can either look for total remaining area, or we can look for high remaining area, low remaining area, car deck remaining area. So depending on what situation we're doing, we might split it, make it three-dimensional. Otherwise, just one on remaining area. And we define these transition functions, as I've said, to specify the amount of space the vehicle will use up. And what we see is, as the ferry gets busier, then the amount of space a particular vehicle type will use up increases, because it's harder to fit them in. And that's what we're trying to capture from the simulation model, this fact that it's harder to fit things in as you get busier. So assuming we're in S, our current state, and here we've split it into 3 dimensions: remaining space on the upper deck, that's the car deck; remaining space for low vehicles; remaining space for high vehicles, both on the main deck. So that will depend on whether we've got these mezzanine decks down or not. Then our next state will be transformed as follows. So if the vehicle fits on the upper deck, we will just subtract something from the upper deck state. If it doesn't, then we'll subtract something from the lower space and something from the higher space. If it's a high lorry, it will only come from the higher space. If it's a low vehicle, then it may actually come from both of them, because often low vehicles will intersect with the high space. So a few results. This is our ferry, picture of the ferry, and the red are the cars, and the grey are cars that require the lift. So cars that need to be close to the elevator or the lift to get access to the deck. Now this is the main deck, which is more interesting, and you can see we've got these different shaped vehicles, these big long blue ones, the slightly smaller freight vehicles in turquoise. The yellows, I think, are caravans or motorhomes of some description. And we can see that you can have different scenarios. Now often if it's a busy kind of tourist time or commuter time, you may well have this one where you've got lots of car demand. This is somewhere in the middle, and then early in the morning when the freight are going over, you will often have a situation where you have lots of freight. Now the green here are motorbikes, and there seem to be quite a lot of them, so there's quite a few fitting in the gaps, and you can see that they fit in quite nicely. So we looked at these 3 different scenarios anyway. What we come up with is looking at these kind of movable decks. I mean, one decision is, because they can make this for every crossing, do we have no mezzanine decks, so no movable decks? Do we have 1? Do we have 2? And you would expect if there's lots of cars, having 2 would work better, and if there's lots of freight, having none would work better, because you then have more high space. And that works okay. I don't think we had quite enough cars, so this one actually came out being better. Now the other thing we can do, which I didn't mention much before, is we can have this non-fixed deck configuration. So we can effectively decide what the deck configuration should be as we go along. And that does come out with some nice results. It's a little bit better. It's hard to say whether it's significant or not, but they seem to be better if we don't fix the decks in advance. And we allow them for this very unlikely situation where, although the arrival rate suggests we should have lots of cars, maybe a few extra freight vehicles turned up. Now, the other test of this is what we're doing here is we're doing everything dynamically, we're taking all the packing into account. The other test is to say, well, what if we took the high car scenario and instead of checking at each stage what else we should add in, we would look at setting in advance the number of each type of vehicle we should have. Now, if we set the number of each type of vehicle that we should allow on in the different scenarios, then we actually end up with lower revenue. So it's better to have this dynamic strategy where you look at what's there, you then look ahead, you see how well it packs, and then go forward. So that's what these results are saying. And then this just gives an idea of what the prices look. It's a messy graph, but it's just to give you a feeling for what's happening to the prices. And you can see here we've got the cars which are going up at the end and then going down right at the very end. And this one is the largest freight vehicles, and you can see their prices go up quite a lot at the end. And the reason for that being that by the time you get to the end, putting one of those in will basically not allow you to put anything else in. And so you're charging those very high prices. If the vehicle really wants to come, then that's great, you will have that high price, but you don't want it to stop you having some of these smaller vehicles on, or several of these smaller vehicles. So, a modest conclusion to start with. At the very least, this should improve the ferry companies' models of vehicle capacity, how much they can fit onto their ferries. What it does is it explicitly models the effect of the packing method on the ferry's capacity. And we can show we've shown elsewhere, I haven't really mentioned it here today, that if you include the packing versus not including the packing, you get much better results. So the use of the loading simulator to track the state in the selling season allows the approach to take the exact effects of the realised vehicle demand scenario into account. So that's a bit of a mouthful of a sentence, but what I'm saying is if we've got the simulator there, then we can really see what it means to have this number of vehicles booked already, and we can look ahead to how that's going to affect the packing in the future. And it also allows this realised demand to determine which ferry configuration will be most profitable. So rather than saying, oh, we seem to have lots of cars, let's have these 2 movable decks down, it can say, well, let's look ahead and see what happens and do it in a more scientific way to work out how many decks to use. So future work, some of this has been done. So this simulated annealing, I think Chris was giving me results at the end of last week. So we think we're just about there now on getting these loading parameters ready. This is something we would quite like to do to see how it would affect things, to actually get some real loaders in to play the simulation game. I mean, it is a bit like a game. You can sit there and work out where you're going to put your cars, if you like, in particular modes of it. And get them, watch what they do, and see if we can use that to develop a simulation that really mimics what the people on the ground or on the deck doing the loading actually do, because that might give us an even better description of how much will really fit in. Compared to existing practices, we have done a little bit, but as with a lot of practical situations, it's hard to really drill down into what exactly they do with the pricing and what exactly they use. And so this is always tricky to say that you're really comparing with what's actually happening in reality. Improving these estimations, this is ongoing, and then looking at something about the discretization. So at the moment, discretization is around the size of the smallest vehicle, which is a motorbike. But there may be better ways of doing that to give us a better idea of the packing, and it's knowing how accurate you need to be on the packing to get a good result for the pricing and so forth. So that's something that Chris is also looking at. Okay, that's the ferry stuff. Would you like me to move on? I'll move on and talk a little bit about research at Southampton and then publishing papers, unless anyone has any questions now about the ferries, because I don't want you to forget all your questions in the next 5 minutes. So I move on to something completely different. Any burning questions now before I move on? Doesn't look like it. Is that right? Good? Okay, I'll go on. I'll talk a bit about Southampton. So, research at Southampton. So what I'm going to talk about is research in CORMSIS, which it's called, and I've realised I've not put CORMSIS on the slides, which is not good. And CORMSIS is our Centre for Operational Research, Management Science and Information Systems. Most of the research is between, and the collaboration is between the Operational Research Group and the Management Science Group, because we're in different departments. So Southampton is strange. We've managed in some ways to get 2 operational research management science departments in the same university. So we've got operational research in mathematics and management sciences in the business school. Now the crossover between the 2 is very hard to see. There's people in management sciences who do very mathematical work. There's people in operational research who are in mathematics who do quite applied work. So it's not a clear boundary. There are obviously people at the 2 extremes in the 2 departments who would definitely be in a maths and definitely in a business school, but there's quite a nice link between the 2. And this work that I'm doing, I'm in the mathematics department. Chris Bayliss is also in mathematics. Tony is based in the business school, even though he has a mathematics degree. And Julia Bennell is also in the business school. So there's quite a lot of links between the 2 groups. So all that I'll talk about today is kind of joint work. So the vehicle routing and scheduling, Tolga Bektas is obviously big in that, who I know has been here before. And then because we're a port city, there's a reasonable amount of work with ports and train and ship scheduling, and people like Patrick Bullens. Airline ticket pricing is how I kind of made my way into this particular bit of work. So there's a little bit of that. The other thing Southampton does a lot of is healthcare modelling. So Sally Brailsford is one of the professors there who's very well known in healthcare simulation. And a lot of hospital planning, operating theatre scheduling, ICU modelling, some facility location actually, which Honora Smith does some work there, locating healthcare facilities in developing countries. She did some work in South Africa with where you should put HIV testing labs, for example. I've got a PhD student looking at dengue fever, which is completely different from quite a lot of the other work I do, but it's very interesting, building simulation models and looking at optimal control methods in this case for finding the best intervention. That's just a taste. We've got quite a big group of combinatorial optimization people, and in mathematics, robust optimization, in finance and other areas. Our head of group works with the European Space Agency quite a lot on optimization. So there's quite a lot of different areas going on, supply chain modeling, for example. So this is just a flavor of what we do. And we do have visitor programs, and we do have seminar series, and we do kind of welcome people coming over. So if you're interested, then do get in touch and let me know. Okay, publishing papers. Now, a lot of you will have published papers, and as I say, a lot of this is telling you what you probably do already. So I doubt there's anything in here that you will argue with, but hopefully it will give you some thought, and maybe give you, those of you who have less experience of kind of going through the review process and the submission process of what happens once your paper leaves your computer and ends up at the journal offices, because I think that probably, I mean, it probably varies a little bit from one journal to another, but the general bare bones of what happens to your paper is probably of use. Okay, so I used some clip art. Do the work. So this is your work, your bright idea. You do the work. Now at that point, I would say before you write your paper, you pick your journal. So you do your work, pick your journal. So first thing, check the scope of the journal. Make sure that the work you'll do fits the journal. So you don't write the paper and then find the journal. You do the work, pick the journal, write the paper. Now, if you're not sure whether your paper fits the scope, then contact the editor. Editors will reply. It may take them a little bit of time to reply, but they will reply to let you know whether your work is within their scope, because they don't want papers that they can't publish. It's time wasting for both you and for the editor. So then you write your paper, and you write it very nicely. You get it checked. You send it to your colleagues, your advisor. They might send it to one of their colleagues, maybe somebody else to read it over and check that it looks sensible and you've not missed any kind of glaring holes in your research. It's very hard if you're the one who's done the work, or most of the work, and you've done all the coding and you've done all the writing. When you come to read it, you're going to understand everything that it says because you've done it. So you need to send it to somebody else who's not been that involved in the work, so that they can say, you know, why did you do that? And how did you do that? And is that bit really important, or is that just, you know, something that you did and then discarded along the way? Do you really need to include it? So I think that's quite important. Okay, so you've written your paper, you've had it checked, someone's read it, they say it's fine. You then go to submit, which is always exciting, I think. It's always nice to submit a paper. You feel like you've really achieved something. So that's where your job kind of stops. So the author bits are in blue. Now this is where it gets to the journal. So the editors will read the paper. So before it gets sent out to associate editors or even reviewers, the editors will generally read the paper, check it over. First thing they will do is check that it's in scope. If it's the Journal of Simulation, we will check that it's got enough simulation in there. We'll check as well whether it's readable. So if the English is not great, you may get it sent back straight away. The editors may say, look, we think it looks like an interesting problem, but we can't understand exactly what you're trying to say at the moment, so please kind of go away and take another look and rewrite it. That shouldn't happen if you've sent it to your friend at this point and got it checked over, because they should be able to tell you that. And then, does the problem look interesting? So we want to know, is it a novel problem? Has anyone done it before? That's where the literature review comes in, because it gives you your way of kind of explaining that no one's done this problem before, it's new, and justifying what you've done. The interesting bit also comes into the scope bit. So is it interesting? And if it's interesting, it's probably within the scope of the journal. So the editors will do that. They may say no, and they may, at that point, reject the paper. And that will usually happen quite quickly if things are going well. That will happen within a few weeks, so you might get a reject relatively quickly. And in some senses, that's almost a nicer reject than if it's been sat with reviewers for a few months and then you get it rejected. Because at that point, the journal haven't had it very long, you can quickly turn it round, you realise you sent it to the wrong journal, you rewrite it for another journal, and you send it off again. So it's a quick process. If the editors think it looks okay, it looks promising, they will send it to reviewers. They may, 2 is the kind of standard, but they may send it to more. Now, be aware, it's very difficult to find reviewers. You will know this, I'm sure. If you try to find people to review a paper, if you're on either kind of editor or associate editor, finding the right person to review the paper is difficult. Finding people who have time available to review a paper is also difficult. Lots of people will come back and say they don't want to review it, which is frustrating. So this bit can take a little while. And it may be that the reviewers are taking a little bit longer, they've got a busy period at work, or it may be that the journal's finding it hard to find reviewers, and all journals have this problem that lots of people will. That perfect reviewer who would be the perfect person to review that particular paper may, for whatever reason, not be able to review it at that time. So it may take a while to both secure the reviewers and get their reviews back from them. So the reviewers will review it, and they will either ask for revisions or reject. They may accept straight away, but it's almost unheard of that they will accept straight away. So you can assume that you're going to go back down here and ask for revisions. At that point, you want to revise the paper, and I'm sure you would do this, but having this nice polite response to the referees where you go through each of their points in turn and address each of their comments in turn, and show the editors that you have done, and the referees when they come to look at it again that you've done that, makes the whole process very easy. What you have to do is turn off your pride. Don't get angry about what they've said. You just have to say, okay, that's what they've said. I'm just going to go through their list and get on and do it. It's very easy when you get that review and you've got 2 pages of this is rubbish and this is awful and you've got to do this and you've got to do that, to get upset and to get angry and to start shouting at the computer, which I think is normal. So you do that for a few hours, then the next day pick it up again and say, okay, we'll just go through the list one step after another, and we won't, I mean, we might shout about the referees a little bit, but we will just methodically go through that, because they're the people who are going to assess it again, so it's no point getting angry or writing an angry response to the referees. If you disagree with something they said, you can politely say, we don't agree with this, and this is my reasons why, back it up, but obviously be polite and don't get angry. So, okay, so you submit it again, which is less exciting the second time around. The editors will usually at that point send it out for review. They'll check that you've written this response. If that's there, then they'll send it back to the same reviewers, if the reviewers are available. And quite often they will maybe ask for another set of revisions. It depends at this point what the reviewers have said. They may have asked for major revisions, they may have asked for quite minor revisions. If it's minor, then it might go bypass this step and go straight to accept. If it's major, then it will go past the reviewers again. In my experience, quite a lot of papers will go past the reviewers twice. There's not many that just see the reviewers once. And then you get your paper accepted, which is great. And everyone's happy, and you've got your citation, and that's very nice. But it can be a long process, especially, and we were talking a little bit earlier about work, which is on the borderline of 2 different subject areas. Then it makes it even harder, because you might have one reviewer, if it's a simheuristics, for example, one reviewer from simulation and one reviewer from metaheuristics. Satisfying both those reviewers can be difficult, and that's where the editor comes in to kind of say, look, we need some compromise here. So yeah, there is some difficulties. Okay, then I thought I'd write what makes a good journal paper, but I'm sure I've missed something, so you can let me know if I've missed something. So this is my perfect paper. Now these things are all to do with the work, really. It's an interesting problem. It's useful, it's high profile, it's an interesting application. So if you're working in an application area, then kind of justifying the size of that application area. For example, the ferries work. The ferry industry is worth however many billion worldwide, will make people sit up and think, okay, I haven't seen many ferries, but now I see this as an important problem, and maybe it is one we should consider. So having that in there is always good. Novel solution. Novelty is what we're after. We don't want to repeat work. And these are all to do with the problem. Then the writing, and the writing is not to be underestimated. It's just as important as the problem, if not more so. Having a good title is great. Something that people will understand with no acronyms in is always good. And it matches the material, so you're not promising something that you're not doing. Well-written abstract. What you have to remember with the abstract is this is your advert for the paper. So when your paper gets published, a lot of people will only ever read your abstract. And if your abstract isn't very exciting, a lot of people will definitely only read your abstract. So the abstract needs to be honest, obviously, but it's nice if it's a good highlight. So this is your kind of advert for the paper. So it's more important than you might think. Just as you would in a PhD thesis, you need to highlight what the contribution is, so the literature review is important. That will help, but also the introduction and the conclusion are important as well. So thorough but focused literature review and clear explanation of the methods and results. The idea of reproducibility is coming into the literature all the way through. Certainly in the medical journals, they want everything to be reproducible. You need to supply your code, etc. I mean, Journal of Simulation, we haven't got to that stage, but I think having that as the gold standard, that someone could pick up your paper and reproduce what you did, is quite a nice way of thinking about, of checking that you've got all the detail you need in there. And then coming back to that, this is just a case of where you send it, that the content matches the journal scope. So if you publish the perfect optimization paper, but you publish it in a medical journal, it's not going to be a good paper for that journal, it won't get found. So you need to make sure your content matches the scope. The editors should pick it up, but you know, it's also up to you to choose where you send it. An imperfect paper. Okay, yes, I remember what I was doing now. So this was my imperfect paper, where everything here is good. So you've done all the work just as well as you've done before. So I'm not saying there's anything wrong with the work, but any of these things could kick it out the door. So you've got bad title, you've got badly organised introduction, so it's hard to see what you've done. Your literature review might read more like a list than a kind of focused literature review highlighting the contribution. Undefined notation and unclear explanation, so the person reading it can't understand the methodology. Or spelling, language and presentation issues can also kill papers, however good this might be. It takes someone a lot more effort to read it if they can't really read it, and work out that it's an interesting problem, or it doesn't match the journal scope. Okay, that's all I'm going to say. So it's probably longer than I said. I always talk more than I say. But if you have any questions. Any questions about anything?
First of all, thank you very much for the motivation and all the tips that you gave about writing and everything. My question will be focused on the main problem that I found very interesting, actually, because it gives us a first notion of the future market, no? The future protocols of negotiation. No? Mm-hmm. How much should we pay for airline tickets? How much should someone pay for using the ferry? No? And this kind of problem I found very interesting, actually, but a lot of things that I didn't understand quite well, and I will ask you some. For example, the probability, if you offer that ticket for that price, how did you, I didn't get the part, how do you know if the guy gonna accept? No? Which probability function did you use?
So we have got one, I think I've got it as an extra slide actually. So this is our price acceptance probability model. It's quite complicated, which is why I didn't put it forward. But what we're basically saying, I mean, this comes from some ideas, economics really, as to why people accept the prices they do. Basically how it works is if the price is quite close to the market price or the standard price, then changing the price either side will make a very big difference in the probability. But if you're a long way away, so if your price is very low, most people will accept it, and changing it a bit won't make any difference. Most people will still accept it, and if it's very high, most people won't buy it. So changing it a little bit won't make much difference. They still won't buy it. So that's the idea behind this pricing function. So
in this sense, this problem is kind of naturally many and multi-objective, no? Because you can consider several points of the ferry to be optimized. For the space between the cars, and also the probability function. It's a kind of multi-agency system that you have bargain between. You can also see it's a multi-criteria problem. No?
Yes, to a certain extent. I think what you're really aiming at, though, that one figure is the revenue, is the thing that you're interested in. I mean, the other thing, you can look at revenue, you can look at efficiency as well. So how well it's packed, and the revenue as well, because sometimes the highest revenue solution isn't the one that is the best packed. So yes, you've got some kind of trade-off there. I mean, what I haven't mentioned up till now is that if you have freight vehicles as well, a lot of them are coming week after week after week, even when the ferry is quite empty. And so if you say that they can't travel or give them too high a price on the busy crossings, then they might not come in the winter when no one else wants to travel. And so you actually lose, although you gain on one particular ferry crossing, you lose over the whole year. So there's those trade-offs which I haven't mentioned, which, yeah, then it becomes much more difficult, which we're looking at, but it becomes more difficult.
And one last question. For solving the mathematical problem, you use like branch and bound, branch and cut. It's mixed integer program or only integer?
Mixed integer.
Mixed. So if you use subtract, maybe it's dynamic search procedure or something like.
So we've got some different ways of doing it. Tony has done most of this, so I'm going to hand wave my way through it. So we've looked at a couple of different ways of doing it. I mean, this isn't what I talked about today. Today is just the simulation, but in the other bit of work, we've used this mixed integer programming as well. And we look at that. We look at a couple of heuristics as well, but the heuristics aren't doing, I mean, they're looking at fewer of the solutions than the kind of exact model, which looks at every possible solution. The heuristics don't seem to be picking up all of the best solutions, so they're not working as well as we would hope they would. And they're a bit quicker, but they're not giving us those optimal solutions. So yes, we've got the kind of exact mixed integer program, and then we've got these
Because before solving the problem, you set parameters with the simulated annealing.
In this bit, when we're doing the simulation, yes, we fix the loading parameters with the simulated annealing, and then we have that. We just look at this weighted sum to decide where we're going to place things. So in that particular bit, we're not using the mixed integer programming. It's slightly confusing because we've got these two methods running parallel. One is solving it exactly, and then the one that I talked about today with the simulation is giving us more.
Because any parameter can find feasible solutions, huh?
Yes, so you can find feasible solutions. You use the simulation to check whether the solution is feasible or not.
Then you can have a pool of solutions that is natural, found from the branch and bound tree. Instead of having only one solution back from each time you evaluate your parameter, you can extract the pool of solutions.
You're almost getting to the method we use in the exact case. Yes, we will look for
that was the point, because this pool of solution is generally intrinsically multi-objective. So you can only filter with Lorentz and have a non-dominated set. Yes. So that's what we do in the other bit. Yeah, I didn't talk much about that today, but you've got it. Yeah, that's what we're doing. Thank you very much.
Okay.
More questions?
In simulation and you link, you have temperature to, and how you tune this temperature.
So this is again, I'm going to pass all of it on to the postdocs. So this is again something that Chris has done, and he assured me, I was asking him this on Friday, and he gave me a response I wasn't completely clear on. But yes, so I can't say for sure, I don't want to tell you because I'll probably get it wrong. So he has tuned the temperature, but that's as far as I will go.
Because I read many papers that show in some scheduling problems that the temperature is not significative. And I do some, I published some paper about this, removing this temperature in my thesis, and put some suggestion that you can put this formula, but it does not need any tuning.
Oh, that's
if
interesting.
You want,
yeah, that would be interesting to know. Yeah.
Because we got the result for this type of the model that we compare different results. In some methods that we used temperature, and in other one that you didn't need any temperature.
Okay.
And we had good results in the method that you don't need any temperature.
Okay. Oh, that would be interesting.
Maybe.
Yes, I will talk to you afterwards.
Because it could be some problem for tuning this for different.
Yes. Yeah. Maybe. Okay. Yeah, I will talk to you afterwards. That would be good. Yeah.
Hi, thanks for the presentation. My question is related with the role of reviewers and taking profit of your visit here and your experience as editor of a journal, because I think some of us are acting as reviewer for different journals, and we can have many anecdotes to explain related with this role. But I was commenting something with my colleagues today about the last paper that I have to review, and I would like to know your opinion. The fact is that I was preparing my report, and I noticed that there were many references to one specific work. Then I was to the list of references. I see that it was about a thesis, a PhD thesis, but it was commented that it was in Portuguese. So, well, I think I'm able to understand something of Portuguese, and I say, I'm going to look if I can find the thesis on the net, and it was there. So I read it, and the content of the paper was almost the same of the thesis. But the author, the main author, or the author of the thesis was not a co-author of the paper, but was his supervisor. Then to me it was very strange to see how the content of the paper was connected directly with the thesis, and the author of the thesis was not then
was not a co-author on that.
So yeah, the thesis is available online, so I think it's more matter of plagiarism in some way, that not because if the author of the thesis is not involved.
I think that's a valid point to make in a review, that, yeah, this thesis, why is the author of the thesis not an author on there? And something, you often get a box to fill in confidential comments to the editor, and that's the kind of thing that you might put in there, that you've got concerns, concerns about that, and then the editor, it then becomes the editor's problem, because it is more the editor's, that's less about your expertise in the subject area and more about how the journal wants to deal with it. So I think it's worth kind of highlighting it to the editor and then letting them go on and deal with it as they will. Yeah.
Yeah, right.
But, for example, I didn't get the point of the question, but for example, if it were the same guy who wrote the thesis, it would be okay, no? If it was the same guy that wrote the thesis, then it, because in Brazil, for example, a lot of people are even defending theses like this. No? In the thesis, you have a chapter that was published in like something that is the same of the paper. So in this case, you would not mind. Is the author? No, then it's very strange for sure.
And the student, that case, was left aside.
I only cannot ask you the name because it's peer review, no? Then we could find that.
Yeah, we won't have that recorded on film. But yeah, yes, I think that does sound strange, but it's often, I think that becomes an editorial decision then, so you pass it on.
It's an interesting idea. I will take that in. Any other question? More questions, please? In the meanwhile, I will ask you something.
You've got all the horrible questions.
Okay.
You've told me what you're
No, but you already know them, so they are not so horrible anymore. So yeah, my first question is about. Well, I think I have a question about the Ferries model, but I think he asked the question already. So I have another question about. I would like to know your opinion as an expert in simulation about which are the future trends that you foresee in the simulation area, like new methodologies or new trends, or the future of simulation itself?
So, yes, no, I was forewarned of this question, so I have had time to think about it. One thing I will say is the Journal of Simulation, this is a blatant plug for the Journal of Simulation, has got 3 papers in this current volume, because we're at 10 years, we've done 10 years, this is our 10th volume. And we've got 3 papers from kind of experts on our advisory board in this particular volume, which are looking at the future of simulation. So Barry Nelson, has done one which is more on input-output analysis. We've got another one from Chick Makel on agent-based modelling, and we've got a third one from a group of authors from Singapore. I think Z is the main author on that one, which is about the kind of more larger scale simulations and Internet 4.0 and all these new innovations. So they're worth looking at because they're quite interesting, and they go into a lot more detail about the future. I think how I see it is, and this is purely personal opinion, how I see the future going, is I think the kind of integration of optimization and simulation will carry on. Simulation optimization has been a big field for the past 5 to 10 years, but I think there's still lots more to do, and the simheuristics is kind of part of that. The other area I think I can see is more of these hybrid models. Hybrid modeling seems to be increasing, where you've got discrete event simulation and agent-based modeling or system dynamics combined together and working together to solve a particular problem. So you've got different bits of simulation for the to suit the particular parts of the system that work well. And then the other one, which is true across everything at the moment, is the big data idea, just how you deal with quite so much data and how much data is coming out of a simulation model, and also some of these ideas of online simulation. So you've got kind of big data going into a simulation model, which then does a little bit very quick simulation and outputs you your recommendations of what to do next. And there's little bits of that going on in kind of some of the semiconductor manufacturing has some of these ideas in it. But there's probably more scope for these online simulations as well that are very quick, very fast, maybe using quite a lot of data and producing some output. So those are the things that I see are quite big areas, and just integrating more with the software engineers. And the other one is cloud computing, which I don't know a huge amount about, but this parallel processing, cloud computing, all of those, and just getting the kind of experimental designs and the statistical processes that underlie it that will mean it's much more efficient, working well. I think there has been some work, but there's more scope in that area as well, in the statistical front. So those are my big things. But yeah, I think there'll always be a place for a simulation that's well done of a novel application area that kind of does everything in a very scientific way and is thorough and well described. I think that will always be there. And there will always be new applications. Who knows what's around the corner? We wouldn't have seen the simulation models of the drones, etc. 10 years ago, we wouldn't have even thought of those things happening. So there's always going to be something new to simulate in the next decade. So, does that answer?
Yeah, perfectly. Another question I have for you is, you also know this question, is what's your opinion about this new or relatively new open access policy in journals, or how do you think it will evolve? Because it seems that it's working quite well in Europe, but for instance in the United States, they don't really care about these open access policies. So what's your opinion as an editor of a journal about these policies? So
we haven't seen much change on this. Certainly in the past 2 years, it doesn't get discussed much at all. And we have all of the OR Society journals have the option to pay for your article to be open access, or you go through the standard route, and then it's available to subscribers. And obviously, funding agencies in the UK, and I assume elsewhere in Europe, want your research to be available because the public have paid for you to do it, so they want the public to be able to see what you've done, and that seems fair enough. But the journals seem to have found ways around that, so you can publish the author version at some point, and that has kept the funding bodies happy up until now. So I don't know. I think it's watch this space, but it seems to have gone off the back burner. We only talk about Brexit in the UK research at the moment, so I mean, these things have gone off. Everything pales into comparison with what's happening with Brexit. So, yeah. Okay, so I have another question yet. This you don't know about it. So it's related with, I mean, I have this doubt because, you know, sometimes young researchers, they come to me or they ask me about what's better if just targeting, I mean, you know, very highly indexed journals or
or being a little bit more open to publish in different journals. So I have my doubts about it, but I mean, I know that also in Spain, for instance, there are some advisors that they strongly recommend their PhD students to publish only in first quartile journals. You know, only it's not first quartile, it's not good research. And in UK, I guess, it's like this. People saying you have to publish only in 4-star or journals. So, what's your opinion about that, especially for young researchers?
So I have an opinion on how I think it should be and an opinion on how you kind of work with the system. I mean, you work with the system, you go for your KPIs, if you like, to use a kind of simulation word. What is going to get you the kudos and the esteem that you need? In the UK, you need 4-star journals if you can, and much below that isn't considered as worthwhile. So we're encouraged to save the work, make a bigger paper, a better paper, and publish it in a good journal, a very top journal, rather than split it up into several papers that might go into a smaller journal, for example, and to really take that extra time to go to a high quality one. But it means you don't publish as many papers because you spend quite a lot of time on each one. The high quality journals also tend to be quite general journals rather than more specialized, and this is my kind of personal opinion, is there is a place for the more specialized journals. So a journal of simulation that looks at simulation is great. A simulation paper published in a more general journal might get lost and might not get seen by as many people. So I think there's a place for both. What I think is a shame is that a lot of the high quality ones are the general journals, which is what you would expect. I think that's naturally how it would fall out. But because of the systems that people are working under, those are the ones that they will target. So as a young researcher, I guess you go for you have your list of journals, your ranked list of journals. If you think the work's good enough, you go for operations research and submit it, or management science and submit it there. They might reject it very quickly. You then go to the next one on the list and carry on down and go with where it rests. That's one way of doing it, but it takes quite a lot of time. I'm not sure whether I'd recommend it. It's a very disheartening process if your paper rests at number 4 on your list, for example. So it's taking the advice of your advisor, who will know roughly what quality it is and where it should go for. So yeah, I don't think I really answered that. I think it's difficult, and it does depend what system you're going into. But in the UK, it's all about your quality. You need to do 4 quality papers by this particular point, 20 something, and yeah, if you haven't got those, then people start asking questions. So yes, it just depends on your system. I don't know what the Spanish system is, but
I think it's quite similar to the UK one. The difference is that we don't have this ABC list. We have we just follow the GCR index. So.
Yes, so you see in maths we have a difference, because the business schools are measured differently in the UK from maths. So management sciences people in the building next door to mine get measured in their journal quality gets measured on the business school list, whereas ours get measured on the maths and statistics lists. So, and we don't have the lists in maths in quite the same way that the business school does, and the reviewers are meant to read the papers and assess the quality, so they shouldn't just look at what journal it's in, but obviously that's going to influence them. So, yes, I think it's tricky. You go where the work fits best, I think.
Okay, thank you. Any other question for our speaker? No questions over there? So, thank you.
Picked on individual.